So let's talk about the process of the eye. So how do we actually see? Now that we've got all the parts and the functions, how do we actually see? The lens is what's really, really critical. So the cornea narrows the light into the pupil, but then it hits the lens, and the lens is what's critical for making sure that you can focus images clearly. The lens is the thing that flips the object upside down. So flips the image upside down. You see upside down first. It's optics. It's just like in a microscope or a telescope where something gets flipped. That lens is constantly, as your eye is moving all over, that lens is constantly moving and changing shape, because its job is to focus the image directly on the retina in the back of the eye. So you want it straight on the back so that those rods and cones, which we'll talk about in a minute, can do their job. Unfortunately, sometimes the lens doesn't change shape either fast enough or adjust its size and shape appropriately. And so you get out of focus images. And those of you that are nearsighted, which you can see near but struggle with seeing far clearly, that's relatively common. It's a genetic condition usually. Sometimes it can happen from development of the eye, for example. But that nearsightedness is because the lens is actually flipping that image too soon. It's short, basically, of the back of the retina. You can see it's too early here. For those of you that have farsightedness, where you can see clearly but struggle with things like reading or computer screens, that's much less common for young people. Instead, oftentimes this is kind of, as you get older, you lose fluid and elasticity and plasticity, and so that lens gets a little bit more brittle with time. And it actually focuses too late. And so it focuses behind the retina. So that image that's actually hitting is just not clear on the retina itself. The farsightedness is a little bit harder to fix with things like contact lenses. Generally speaking, nearsightedness is what you're going to be able to fix with something like LASIK surgery. Some people have the unlucky both, where they are nearsighted or they are neither nearsighted or farsighted, and they struggle with both, in which case they might need a bifocal, for example. Once we get into the back of the eye, the retina itself is where transduction happens. So every single one of the senses has a location for transduction, and it has certain cells that actually make transduction happen. Transduction being a transfer of energy. In the case of sensation and perception, that transfer of energy is actually taking the distal stimuli, so whatever the stimulus is that's coming in from the outside, in the case of vision, it's light waves, and it's translating it into a message, a language that the brain can understand, which is only neural impulses. So the brain can only understand those messages on those sensory neural pathways down the optic nerve. So what we have is the retina that holds all of the cells, the photoreceptor cells, that can actually translate those messages. Those photoreceptor cells are called cones and rods. Right in the center of the just basically next to where the optic nerve and the retina meet, there's a cluster. That whole cluster, that whole area, is called the fovea. That's where the majority of your cones are clustered. So they're right in the middle of the retina, and that whole thing is called the fovea. It'll be responsible for your foveal vision. So anything that your cones are doing for you is your foveal vision. Cones, if you can remember, are color vision, bright light vision, fine detail vision, and central vision, so right in front of you. If you can remember that, you can remember the opposite of that, which is all the rest of the area of the retina. There are rods, and those rods are black and white vision, dim light vision. So at night, your peripheral vision is actually clearer. So peripheral, dim light, and nighttime black and white vision. You can see without functioning cones. It's called color blindness. You cannot see without functioning rods. So those black and white feature detectors being able to activate. We're going to do this demonstration in class. Once you get to the fovea, the location here, the fovea where those cones, and if you look all the way around is where the rods would be, directly where the optic nerve meets the retina, you can see kind of this divot right here. This is what's called the optic disc. There are no rods and cones right where those two things meet, and therefore you can't see, and it's your blind spot. We'll do a demonstration of that in class.